Okay. So you can see my screen, right?
Yeah.
So we should draw a vector scale diagram and represent the displacement of the boy from the time he realized he left his school bag until he reaches home, right?
Mm.
So they say from the time he realized he left his school bag. So he realized he left his school bag at like 500 meters, right?
Yeah.
So I'm just gonna use this scale for for you to get a better idea of what's going on, right?
Okay.
So this should be like 5 centimeters when you're drawing it down.
Mm.
So at 5 centimeters, that's why he realized that he left his school bag. So from 5 centimeters, he goes back to school, right?
Yeah.
Then here, let's say it's 13 centimeters because of this.
The photo. Mm.
Yeah. So
You're fine.
after that, he's gonna have to walk back home from school.
Mm.
Yeah, so like these are the two vectors that represent the displacement of the boy from school then back home, right?
Oh, you said, oh.
Yeah, that's all. Like he midway he realizes that he forgot his school bag. There's a vector to show that. Let me
Mm.
just let me just like
Oh, you
highlight
did you
it.
did mark for the directions of the arrows.
Yeah, let me just highlight it. So this is for him going back to school. Then
Mm.
the one on top is for him going back from
And
school
back
to
from
home.
school to Mm.
Yeah, then that's it.
Okay.
Yeah, like the thing is, I think you need to label them, you know.
Yeah, school.
Yeah, that's why I just wrote
Housing.
S, then
Mm.
H for home, you know.
Yeah.
And they say if the average speed of the boy is the same as that of the girl, calculate how long it will take the boy to reach home from the time they both left the school together. So let's say they both work at the same speed, right? Let me just
Mm.
cancel these. I'm just gonna take this because it's gonna give me a more accurate answer than
Yeah.
like the answer that you run it off.
Okay.
So for me, every time like I'm gonna place it by velocity, I'm just gonna put 13 over 18, right?
Okay.
So if they both walk at a speed of 0.72 meters per second,
Mm.
how long is it gonna take the boy to reach home from the time they both left the school together? Okay, so we're gonna take 500 meters, right?
Mm.
The 500 meters he initially walked and
Yeah.
500 meters walking back to school because this is another 500 meters.
Yeah.
So then he walked all the way from school to home. So that's 1,300 meters or 1,300 meters, right?
Mm.
So the total the total distance total distance that the boy walked, right?
Mm.
That's gonna be equal to 500 plus 500 plus 1,300. You understand why, right?
Yeah.
Okay. Then that's gonna give us 2,300 meters.
Yeah.
Then from the equation of average velocity, or just the velocity equation, we know that v is equal to delta x divided by delta t, right?
Yeah.
Therefore, we cross multiply this. We're gonna get v delta t is equal to delta x, right?
Oh, what did you do there?
You cross multiply them.
Because what? Cross multiply what and what? Oh. Oh, okay, I see.
Yeah. Then you see that. Then I just divided both sides by the velocity, right?
Mm.
Therefore, delta t is equal to this, the change in distance divided by the velocity.
Mm.
Okay, so let me just rub this. Let me just rub this out. Yeah, let me just rub this part out. So we know T is equal to delta x divided by the velocity. Let me just erase this one and this one. That's fine, right?
Yeah.
And we're gonna get 2,300. That's gonna be divided by the velocity, which in my case, I'm just gonna write 13 over 18 in brackets.
Mm.
And we're gonna get our answer, 2,300 divided by 13 over 18. That's gonna give us 3,184.62 seconds.
Yeah.
Yeah, so this is the time that it's gonna take the boy to get
The
home.
H.
Yeah. So yeah, I think that's the entirety of question 2. Do you have any question on this?
No, I actually understood this.
Okay.
Yeah.
Then you're gonna do like question 3 on your own.
Mm.
But whenever like you feel like you have an issue, just send me a message on WhatsApp. Okay.
Okay.
Let me just stop the recording.